Welcome to part 3 of our journey into the client types. We're going to learn about the logic, how players are matched, and how they exchange messages. We're going to learn about two very important commands in NodeGame, which is node.done and node.say. What the node.done does is to terminate the current step. So if all the players have pressed the button to make a decision and the background code has sent the node.done message to the server, then the server will go to the next step. So this is how synchronization is achieved. Node.say is also sending some data to the server, but is nothing to do with terminating the step. On the receiving side, the code that is required is different. In the case of node.done, the messages are automatically inserted into the memory. There is no need to implement what's called listener. And then while node.say, you always have to implement a node.data, which is some data is coming into the client to actually do something with the information. Okay, let's have a look at the code. So I already opened the logic client type. See how it looks? It looks pretty similar as to the player. See they both. This is the player. Actually, I'm going to put them one side by side. Left hand side is the player, right hand side is the logic, so they're pretty similar. They both begin with the module export definition, which receive the same object. The player starts with the definition of the quiz text. The logic has some methods to set initialize the client, but it's not doing anything. And you see that the first stage or step which is extended is the ultimatum. While the player already has a lot going on in the init, so this is empty. This is creating the widgets and setting up all the variables. The logic is doing nothing. It's the same for all the steps before. When there's nothing to do, just receiving the information, you don't need to extend those steps. For example, the select language, the logic needs to do nothing, it's just receiving the information. Same for the instruction, all the demographics, all these methods which are just player, basically single player decision, the logic needs to do nothing. So the first thing where there is some interaction is on the bidder step. If we remember the game sequence, the bidder step is one of the two steps of the ultimatum stage. And here where we start. You see, we're extending the ultimatum stage to take into account what the players are doing here. So this is a game which implements the roles. So in the player, there are two roles, the bidder and the responder, each of which has different things going on. For example, the bidder role has a bidder frame and some information here. The responder role has a responder frame and is doing something different. And we also have a solo role in case we have the game played with an odd number of players, so one is just doing nothing basically. Okay, so let's see the logic more, what is it doing. So there is an init function. We will see later what that means. I want to show you this step here. So we're extending the bidder step. The bidder step again is the first step of the ultimatum stage, which is composed by two steps and which is repeated a certain number of times, which this value coming from the settings. So ultimatum stage takes the repeat value, in this case equal to, from the settings, and is repeated 2 times. So the sequence would be bidder, responder, bidder, responder. In each round, we want to have a round robin assignment of this role to the player. So if this is randomly assigned, so the first one of the two players connecting will be a bidder and the second one will be the responder. Every time the game returns to the bidder step, they're gonna be inverted. So if I was the bidder, then I will be the responder in the next step. And all this is very easy to be implemented, just a few options. What happens when the player is a bidder? When it's a bidder, it is implementing the widget step, which is asking for an offer between 0 and the number of coins which is available. The next two functions which needs to be implemented is the time up and the down function. Basically, the time up is what happens when the timer runs out, if there is a timer. In this case, it will make an automatic bid, and it will call node.done to signal that the step has terminated. When this is called, if it is defined, it will call the done callback, which makes some cleanup and sends the information to the server just before terminating the step. In this case, it's basically writing to screen, this is your offer, and now we're waiting for the responder. You see that the done callback on the player returns a value. This is actually what is sent to the server. Let's see what happens to learn the journey of this object offer, which contains the value of the offer of the player. The logic in the ultimatum stage implements an init function. So as soon as it enters the ultimatum stage for the first time, it's defining a number of views on the memory. We don't look at the memory right now. We just look at the exchange of messages, and also define a listener. So when a data message, which contains the done label, which is what this done callback is sending, this message is going to be evaluated. What we want to know is who sent it. It was the bidder, because inside the inside the ultimatum stage, it could be the bidder, or it could be the responder. And we check. So we are in this bidder step, and this is the bidder. So we're going to tell the partner, we're going to tell the responder what was the offer, right? So this is the journey. So the bidder sends the done message to the server evaluates it, and then sends it back to node.say with the tag bid to the partner and the value of the offer. The responder, which was just doing nothing, in here it is waiting for the bid message to be received. Once it is received, it stores its value and it sets node.done to terminate the steps. Now both players are done, the bidder and the responder. So the game is going to advance to the next stage, to the next step, which is the responder step. In this case, we have the responder first. Here we see that basically it's waiting for the user to click one of the two buttons which are available. Let's have a look at the screen to have a better idea. First of all, let's move the repeat stage with the ultimatum stage first, so we're not going to lose time. So we're going to start exactly directly into the ultimatum stage. So I'm the bidder, so this is the widget step that asks me for an offer. You see, it is exactly this information here. So this code here is generating this screen here. Now I'm making an offer, pressing done, which calls node.done, and it sends the offer to the server, and the server already sent it to the responder, and which got it back. So it was very fast, and we already are in the responder step. Now I'm playing as a responder, and I got the offer, and I have these two buttons here. Let's see what can I do here. So these are the callback of the step. I can either accept or reject by clicking on one of those two buttons. You see, this is w.get, means get element by ID. So there are two buttons. One button has ID accept, the other button at ID reject, and we're just intercepting the on-click event. So when the user clicks on either button, this function is executed. What this function is doing is basically bubbling up the decision. It's using the method node.emit which calls for any local listener for this event. So where we define this local listener, we go on the actually init function. We see this, we have it here. So notice what the comment says. It doesn't need to be done in this way, but this shows you how Node emit works as well. So you could have directly wrote this code inside those on-click listeners, but this shows you a bit how to use these functionalities as well. So when you have the response done, we still don't know which one, you have it here. I'm going to write the type of response that that you chose inside the element with ID container on the page. And then we're simply stay node.done with our response. Now if you follow, this node.done is sending the response to the server, so we're back in here. But in this case, the role is the responder and the step is the responder. So what it's doing is just sending back the response from the responder to the partner. See, we've got the partner ID from here, and which means that it's below here. Sorry, was here. Sorry, which means that this function is going to be called. This function is going to be called on the response. We're stopping the timer, which was taking to see how much time we were left to receive the response. We just write to the screen what the response were. And then we use a random time interval from 1 to 3 seconds to also do done. So in this case, the user does not need to click, it just needs to go through the next step, to the next step. So this is it. Let's see if it actually, let's see if it's doing so. And this time I'm the responder first. I'm waiting for an offer. If I inspect this element here, you see there are two buttons. One is accept, one is reject. These are the IDs here. So we are basically, if I click here, this is going to be executed. So I'm going to accept the offer. Now I'm waiting, and now I am the bidder. Waiting for the responder, sent to the server sent it back, my offer was accepted, and we already played the ultimatum games 2 times. That's it. We have watched the interplay of messages between clients and server, and also in the presence of roles. So this is a broad overview of how the exchange works. The next video we're going to see how the data is saved, and this is also quite important to understand how that works. So stay tuned for it.